Hey guys, welcome to my channel, and in this video we're gonna create the world's most beautiful weather application, or if not, one of the world's most beautiful weather applications. Honestly, I really can't wait for it to have it for myself, so let's do it. So what does the world's most beautiful weather app look like? I think it looks great. But other than that, a good UI and a good UX is what makes an app beautiful for me. So in order for an app to have a good UX, I think it should be informative, it should be easy to use, it should be performant. And generally speaking, an application with good UX doesn't make you think. And what that means, actually it takes a book to describe it. It's one of the best books about UX, but in a nutshell it means that every information is presented to you at the right place and the right time, and you know where and how to get those data. So you always feel in control, you always have an idea of what every UI element is on the page. You don't come to ask for yourself, oh, what does that button do, or where do I get that information? When you find yourself asking those questions, probably that's not the best UX that they could have come with. So I just had to review about 100 weather app designs just to make an idea of what's possible for a weather app and what critical information should be presented undoubtedly. And although every design was special in its own way, I think I found one design that stands out for me amongst all the designs. And the reason for that is being minimalist and informative at the same time. So let's see it. So the winner of all weather app designs belongs to this design, and as you can see, it has lots of white space filled with a bluish gradient color, but that would be changed according to the weather. So if it was a sunny day, it would be a yellowish one. Right now it's a cloudy day, so it's a blue one. And in the center of the screen we have the forecast for today presented in a minimal way, like you would only get the temperature, chance of rain, humidity, and wind speed. Nothing more is presented on this page, but that normal button would show you more information if you need to. And down there we see the forecast for the upcoming hours, so presumably we can just scroll it to see the rest of the day's forecast, and that 7 days button would take us to the next page, which is the next 7 days forecast. Also, tomorrow's forecast is a little bit emphasized by creating its own card top there, and overall this is the best design I can think of. Let's create it in Flutter. But just before we get down to code, let's figure out our API provider, and after searching for a couple of hours, my take is that AccuWeather, OpenWeatherMap, and WorldWeather Online are the three most reliable weather APIs that I can use. But beyond that, there are two non-profitable organizations. One is NOAA and the other one ECMWF, which provide their own weather forecasts and have their own REST API. So I may use them as well, but for now I'm gonna stick to OpenWeatherMap. But I'm gonna implement my API layer as something like repository pattern, because I want to have interchangeable API sources, so I may have another API sources as easily as implementing a new repository class. All that said, let's now jump into the code. So let's see the code base, or how this is built. It's built with Rx extensions and an architectural pattern that involves blocks, services, and managers. Services are kind of modules, or just as the name suggests, services that takes some time to initialize. For example, database, you need to call a connect method on it, so you need to put a await before it, because that's asynchronous, so that's not a synchronous class that you can just initialize and start using it. Another example is env service, which is you are loading your env file and putting it into a global variable, and that loading file is asynchronous, so you need to load it or any other service once in your application and use it everywhere else, so you wouldn't starting services, awaiting for services on every page that you need. So blocks, on the other hand, are business logic components. It's first, I think, popularized by Google on Google I/O. The idea is business logic components, basically decoupling all your business logics into blocks. So here, for example, for my weather app, I've created weather block, geo block. I also have position block, which is responsible for interacting with geolocator service. So you see the relationship between here. Blocks basically use services to get their things done, and also there are managers, which are classes which are sync, like your API class. You just initialize it and start using it. and blocks also use managers. So all that said, you could implement your block pattern with any other packages. I've used RxDart because it has lots of capabilities, and instead of providing its own API like observable or observers, their equivalent would be the observable would be the stream, right? So, and the observer is the listener or subscriber to that stream. And the behavior subject is simply the stream controller. Instead of RxDart introducing its own APIs, it would be using like all the stream capabilities of Dart, so it would be integrated seamlessly. And that's my choice for Rx. Also, Rx, as you know, the concept is so much powerful. The concept of streams, listening to streams, just to make an idea of how much that is powerful compared to an imperative approach, like for example changing a setting and you would need to call all the blocks, for example, or all the methods that you need to update things. On contrary, this method, updating the behavior subject, all the listeners would react to it, some blocks would call some code, and of course the UI changes thanks to stream builder widget, which is a widget that gets on a stream and returns a widget, and you have the snapshot of that data on the builder argument, so you get the stream value and return your widget based on that. So for example, here if I change my metrics to imperial, you see that there are stream listeners on the blocks to this value, and all that blocks would call the code based on these settings change, so no imperative callings are involved here. That's the whole idea, I think, but just to clarify a bit more, I've used some packages for my splash screen, for my launcher icons. You can check the configs, it doesn't have any specific thing to explain. We have Flutter, platform widgets. This is the library that I use for creating adaptive widgets. So if you check the package, you would see that it has almost every widget for the adaptive ones. And also you can check the services here for services that I explained, and the service provider is a singleton in the class, which, as I said, that you need to create all those services once and using the application. This is the singleton that has the responsibility of this thing. You can check the code at this URL. It is open source, MIT license, pull requests are of course welcome if you care. And to organize my widgets, I have separated them into pages and components, and pages are equivalent to routes on your application declaration. So every route would return a page for it, and each page would have some components or widgets inside that. And also we have this weather forecast model, which is mapping from every weather provider to the class happening inside these factory methods. It's basically reading the JSON data of, for example, your open weather maps daily forecast and mapping it to a weather forecast instance basically. And also I've written some tests for these adapters basically. So this is a test for the weather forecast object. I'm basically passing it a JSON file to it and testing every single parameter of the class to be equal as the one created on the JSON file. So I'll be sure that the class gets constructed with correct or right parameters and nothing gets skipped in between. And this is the same unit test for the location object. So this time I'm giving it a reverse geo object and expecting everything to be correct. I also have some integration tests, so I'll be sending actual HTTP requests to the endpoint and assert that I get everything correctly. So since I don't know their responses, so I just expect them to not be null or be null in some cases depending on the method that it's or the test that it's running for. I think this is all of it that I needed to explain. Please tell me about your thoughts. I really mean it. Tell me what you think about it. And check the code, of course. Pull requests are of course welcome. And please subscribe, because on the next video I'll implement this next 7 days page and also publish it on Google Play. So basically sign our app, obfuscate our application, probably minify it. All that would happen on next video. So please, I'm begging you, subscribe. Anything else? I think no. So see you in the next video. Bye.